Welcome to the second video showing the different Godot orbits projects that will be released on GitHub soon. These are currently running on Godot 3.4, but can be ported to the version 4 easily. The first project used a custom class called a K-Planet that applied Kepler's formulas to solve and visualize basic orbits on rails in 2D. Check out the channel if you missed that video. This second project uses Godot's built-in gravity physics and 2D rigid bodies to simulate the paths of multiple celestial objects orbiting around a central star. The main game scene consists of a slider that controls the simulation timescale, as well as the central star body and a single starter planet. Both are rigid body physics nodes. The interface also has a UI panel for logging important events, and several Area 2D nodes for testing different scenarios like increasing and decreasing velocity. While the simulation is running, you can add new planets to the space with the mouse. By right-clicking, we can create a new planet and give it the correct velocity so that it has a mostly circular orbit. By using left-click, we can create a planet but not give it any velocity, resulting in the planet in free fall towards the star. So let's look at some of the GD script code. The main game scene handles the basic UI interactions like adjusting simulation speed, zooming in and out, and logging important actions to the screen. It also handles the creation of new rigid body planets in the simulation and giving them enough velocity to have circular orbits. Finally, it handles the special Area 2D nodes that we'll use to test special scenarios like speeding up and slowing down objects. The next two nodes are the main rigid bodies in the simulation. These are the star node and the planet node. Both use the Area 2D gravity point setting to handle the effects of gravity on the bodies. In addition to handling gravity, the central star node also has a heat zone Area 2D. This handles the event where a planet gets too close to the star but doesn't collide, causing the planet to lose mass while in the zone. The star also sets max diameter of the simulation space around the star. Any planets that go beyond that will be removed from the simulation. The planet node is responsible for drawing the path the planet has taken so far, updating the UI with useful HUD values, and handling impact collisions and merges with other planetary masses. It also has some utility functions for speeding up and slowing down the planet, which we'll see in a moment. Let's see it in action. The game starts with a single planet. Then we use a special Area 2D node to emit a second planet. Each planet draws some important parameters and various lines to the screen. As the simulation runs, if a planet enters one of the special Area 2D nodes in green, blue, or black, we perform some special actions. The green area is one of those special nodes. In this case, when the planet enters the node, it is given an increase in prograde velocity. This results in the orbit becoming more and more eccentric over time as the apoapsis gets further away from the star. The blue area node has the opposite effect. It will dampen the velocity of the planet, slowing it down until it ends up colliding with the star. The third special area is a black circle. This is a void, and any planet that enters the area will simply be removed from the game simulation. Because these are rigid bodies, we can detect collisions between planets. When two planets collide, we calculate an impact score. Depending on the impact score, we'll either bounce the planets apart or merge them into a single more massive planet. This can be seen in the log panel as the collisions occur. Let's add some more planets to the simulation. We can control the starting velocity of new planets using the mouse. First, if we left-click, it'll create a planet with no velocity, and this causes the planet to plummet directly towards the star. Second, if we right-click, it will give the new planet a mostly circular orbital velocity. The planet will continue in this orbit unless disturbed by other planets or if it enters any of the special Area 2D nodes. And things can get pretty chaotic when we add a lot of planets. There's a demo of this project on the channel, so be sure to check it out. And that's the tour of the second project, using the Godot gravity physics and rigid bodies to simulate simple 2D orbits around a central star. Like I mentioned, I'll publish the entire project to GitHub soon. Our goal is to reach 250 subscribers before we do that, but we might give early access to the private repositories before then. Drop a comment and let me know if you're interested. Watch out for the third video, where we'll take 2D orbits even further and create a simulation containing both planets on rails as well as dynamic end-body masses. Thanks for watching.